This is how the equilateral triangle is, with one side of length x, and it's getting bigger. The rate at which the side length is increasing is like this. It's the increasing rate of x, right? Got to think about the rate of change of x, the rate of change of x with respect to time, dx dt. X is getting larger. There is an equilateral triangle with a side length of x, and it is growing in size as x increases. The rate at which the side length is changing is 4, so the derivative of x with respect to time, dx dt, is 4. Therefore, is this statement accurate? If one side gets longer, of course, the area will also get bigger. The next question you asked us is what? So what we're trying to find is how the area grows at a certain speed. In other words, they're asking us to find dA dt, which means they're giving us dx dt and asking us to find dA dt. It's a problem like that. But you know, guys, even if the length of one side is growing at a constant speed, we don't know if the speed at which the area grows is constant. You know what I mean, guys? When multiple variables are intertwined, we don't know if one variable increases steadily, whether the other variable also increases steadily. It's a problem of finding dad t, but this dad t can vary depending on t. If there's no condition, what do we find? When can I get dad t? When x is 53, they always ask us to find the rate of change, right? They're asking us to find the rate of change at a certain moment, aren't they? Essentially, this problem involves determining dx dt and computing dad t. However, at what point in time does this occur? What should we do when x is 53? We need to find the derivative of a with respect to t. What information do we have? Dx dt? Then I need to find an equation that includes both dx dt and dA dt. So how do I find an equation that gives me both of these? Well, I just need to differentiate an equation with respect to t. What is the equation that involves the variables a and x? What's the relationship between x and a? You know, a square is about side length and area, right? So can't we find the relationship between a and x? So if you differentiate that equation with respect to t, both dad t and dx a dt come out, right? So if we substitute 4 into dx a dt, isn't dad t what we need to find? So now, if we look for the equation for a and x, the area of an equilateral triangle is 1/2 times the length of one side times the length of one side times sin, 3p, which is equal to 2, 3. Therefore, we know that the area of an equilateral triangle with a side length of x is equal to 4, 3 times x squared. You know what I mean, guys? How do you expect to do this? Why do we differentiate both sides with respect to t when we differentiate with respect to t? Since we're trying to find dA dt, the only thing we know is dx dt. So if we differentiate both sides with respect to t, dA dt would be equal to 4 times the square root of 3 times 2x times dx dt, right, guys? It's over, right? I think we can find dA dt by substituting dx dt that we know into 4 and x into 5 square root 3.